So welcome, this is step 4 of using the tool calling in LangChain.js. So in the previous video, in step number 3, we actually used the bind tools method to bind our LLM with the tools. The two tools that we're using is a multiply and an add function. We did some tweaking with the system messages, the description and the name of the functions, and we were able to invoke the LLM and correctly at the end get the correct responses. So when we asked what is 11 plus 49 or what is 3 times 12, we got back the correct arguments object, and the LLM was smart enough to pick the right tools given the question. In this step, I'm going to take the output of this invocation to the LLM and try to pass this to the actual functions. Now there's something that we need to clarify at this point. So tool calling, even though the term is called tool calling in LangChain, it's not actually calling, it's not actually executing the function. So tool calling is all about picking the right tool, create the correct or the appropriate arguments, and preparing our application to execute the function. So tool calling doesn't actually call the functions, it just prepares us for this next step. So once we have the response from the LLM with the tools, we are ready to pass this response, to pass this argument objects to the actual functions and get back the result from these functions. So let me console log the methods again with some messages. So I'm using the message which asks about the multiplication and an addition. So let me try this out, and let me just stop the code for now here. Then I will just continue. So let's see number 4, what messages we get back from the LLM. Perhaps we might need to tweak it a little bit with our prompts. So given this question, we get our tool calls. So our AI message contains this property tool calls. It correctly decided to use the two tools available, multiply with these two arguments. And as you can see, the arguments object conforms to the schema. So A and B, properties A and B with 3 and 12 as numbers. And then it picked add, the add function with the values 11 and 49. So in this video, I'm using like a simpler setup for my tools. In the previous video, you'll see we had to do a little bit of tweaking with the description and the names, and also provide a system message here to make the system a little bit more flexible in the answers that it provides and the decision that it had to make with which tool to use. So I'll go back to the previous video to see what exactly we tweaked. At this point, given this question, it correctly gives us the object that we need to pass on to the actual functions. So once we have this output, so I'm just going to console comment this, we go on to the 4th and last step of setting up the tool calling process, which is all about tool execution. So the tool now can be executed using the arguments that the model just provided. So these arguments will be passed on to the tool. Remember, I mentioned that tool calling is not about actually calling the tool, is about preparing for the tool execution. So now that we have this like response, we need to make an object. This is just for so this is just a simple object with these two properties which contain the name. So these two keys correspond to the name of the tools. So if you remember, our tools in this case have the name add and multiply. So these two keys are included as keys in this object, and they reflect their values, actually reflect the actual tools. So the add tool and the multiply tool that we created using the tool method. So the name of the tool goes into this object as the key, and the actual tool, the variable that holds the tool, is placed here as the value. Now we want to use this because the methods here, if you remember, the tool calls array contains the name of the function that's found in here. So it picks the tool and then it picks the name property. So this value is taken from here. If this had another name, like, I don't know, Fet's Wikipedia page, it would state this in here. So this corresponds to this name property, but we want to these two like descriptions of the tools to actually correspond to the actual tool that we created earlier. So this is just a simple dictionary, let's say, setup. And once we have our AI methods, so this is the AI methods that we see in here, we will loop over the tool calls array using a simple for loop. So for every single object found in here, we're going to loop over and then grab the tool call name. So for the first object, grab this name. So this, in the first iteration, this will be multiply. In the second iteration, it will be add. So loop over, grab the name of the tool, and then using this dictionary that we created, we now can pick up the relevant tool. So if this is add, it will go to this object, and add will correspond to this tool. And if this is multiply, in the second iteration, in the first iteration it's multiply, it will pick up this key, and through this key we will get this value. So this is actually a dictionary to help us get the appropriate tool based on the tool's name. So that's the selected tool. And then what this gives us, what this tool object gives us, a way to invoke, to actually execute the function that's contained in this tool. Remember, the tool is not just a function, is an object that contains the function plus some schema, some metadata. So we can say select the tool invoke to actually execute the function for this tool, and for the input we provide the tool call. So basically this whole thing. Okay, so and the invoke method is smart enough to provide the part that's relevant to the actual function, so the arguments and their values. And of course, I'm console logging here to see what kind of a tool is actually executed. When I ask the LLM a few questions, I get a response back, which is another type of a message, the tool message. And then I'm pushing this into the array of messages that we've been keeping so far. So basically this is like a dialogue, this is a chat model, so we're keeping this array of messages, the system methods, our users' methods, our users' questions, the responses we get back from the tool calling, and we create kind of like a thread, like a dialogue. So now the LLM has the system methods, it has our question, it has the response from the functions, from the tools, so it can probably come back with a final response. So given all these messages that include both the question and the answer, we invoke the LLM, and we're waiting for the response. So if I run the code now, remember the question in here is what is 3 times 12 and what is 11 plus 49. Let me see what we get back. So let's see what we got back. So first of all, through the console logs that we put, we're seeing here that it actually picked the multiply tool, and it and it executed it, and it called also the add tool. So for this question, it picked these two tools, one for its operation, for its of the relevant parts in our question. And then it produces something interesting and a little bit weird. It says to calculate 3 times 12 and 11 plus 14, 9, I can use the following Python code, and we can run this code and we get the output. And we see here that it's correct, but it's kind of like weird. Like I do not care about like Python code, and it's kind of like strange because it didn't use Python. It used some JavaScript functions to get the output. So there's some irrelevant, let's say, information or details in this response, but the response is correct. Let me check this with another question. So what is, I don't know, let me just see whether it will, 3 times, I don't know, let's see how this goes. We should have just one call to the multiply function. We see we get an error. That's because the receive tool, which is probably the multiply, was given the wrong schema, the wrong arguments object. As you can see here, the output, the error throws also the arguments object. You can see that it correctly created the structure of the arguments A and B with the two values that we provided, but the type is not a number. It's not a number, it's a string. So the function has thrown an error because it didn't get the correct schema. So once again, we need to do some like prompt engineering here to actually change the description, in this case, of the tool. So I will go here and I will say multiply two numbers instead of just multiply. So multiplies numbers A and B. The arguments A and B must strictly be numbers or of type number. Now, since I changed the name of the tool, I should go in here. In the dictionary and change also the key here. So it was multiply before. Now I change this to multiply to number. So I should also update this dictionary. And now let's see whether we get a correct argument object using this simple tweak. Once again, we got the incorrect output. It's still throwing an error. Let's see how we can make this. So multiplies A and B. The arguments A and B must strictly be of type number. This is not enough. So let me add a system message here. I've already commented one. So I'm going to uncomment this. So you're a helpful assistant. Try to answer the questions provided by the user using your knowledge, or use a tool to provide the response otherwise. Try to be specific with your response and not give details that were not requested by the user. This last part I'm placing because I don't want the LLM to produce these weird Python things. I just want to give them the response or the result of the operation, the multiplication or the addition. Now, let's see whether this prompt helps us get the correct. So as you can see, just by tweaking the system methods, I get the correct output. So it called the multiply two numbers tool. The result is correct. Let's check with the rest of the questions here to see how well it performs. So just how are you today? Let me put a comma here. Extensive testing and evaluation. So I'm functioning properly and ready to assist you. That's really good. It didn't mention anything about Python or mathematics, so that looks good. And 0 calls to the tool calls, no tools, sorry, were actually used. What's 11 plus 49. To calculate this, I can call the math tool. This is once again irrelevant. We get the correct result, but we have this, these things that really don't want to see in here. First of all, it didn't call the math tool. So in here, we just probably want to update our system methods here, and I think I should. Let me try to put this before like the message. Let's see whether it gives me a different response. Maybe the order matters. Okay, so these had to be in the correct order. First the system methods, then the human methods, and given this like instructions gave me the correct output. As you can see, there's no mention about math tool or code or whatever. The result is 11 and 60. Okay, let's try the multiplication once again. The result is 36. That's good. And let's try this two more, given that we made some changes. So that's correct. And now the big test, all this together. The tools 36, 60, and let's do another test. So a new human message. Let's push this to the limit. What is I don't know, 3 times I don't know. Also, how much is I don't know, 99 and whatever. Let's see. We just don't use the arithmetic operators. Maybe. Okay, correct the first one and correct on the second one. So it's working pretty well. As you can see, we don't have to provide the symbols here. So basically that's it for the basic setup of LangChain with the tool calling. Let's sum up. Now let me just fold a few of the code. So we instantiated our LLM model using the chat or llama class. Remember that chat models are the ones that can use the bind, that we can use them to bind them with tools. Simple models don't really have this support. You can also use ChatGPT or OpenAI or another LLM through an API. We defined, in order to create the two tools, or we can even provide more tools, we defined 2 functions, 2 simple JavaScript functions. We defined their schema, meaning the type of arguments and the values that they accept. Then we bound these 2 together using the tool method, so the function plus the schema plus some extra information to actually create the special tool that we need to bind with our LLM. We put all the tools together in a pack, in an array, and then we just bind the LLM with our tools in a single command. Then we use some system methods to give some guidance to our LLM, and the human methods to just ask a question. And then we invoked the LLM that is bound with the tools to get a response. And then we pushed that response to the messages array. We went on and try to find whether the response of the AI contains some calls to these tools. If the LLM decided to call a tool and included it in its response, we went through these tools, we executed them, we got back some response with the returned value, and then we pushed that also to the array of messages. In this case, the LLM is invoked with this thread of messages. So system methods, the initial question, the result of the invocation, and the tool calling. So given all this information, it sums up and then gives us the response that we got. So this is a pretty basic setup for using tool calling. You probably already know by now that describing our function names and describing our making the description a little bit more detailed, as well as providing system messages, is important in order for the LLM to provide the correct responses. And the last thing I want to share is I will go to this link. Okay, so tool calling. No, sorry, this is, let me go. Something that is important is to go to the documentation page of LangChain and read the best practices when it comes to tool chaining. They have some really good tips. So when you're using tool calling, there are some important things to keep in mind. So models that have explicit tool calling APIs will be better at tool calling than non-fine-tuned models. So this means that you have to check this link with models that are specifically crafted for to use like tool calling. There are other models that don't really work well with tool calling, so it's a special feature that became available in some models. The models perform better if the tools have well-chosen names and descriptions. You saw that when we tweaked the names and the descriptions of the tools. Simple, narrowly scoped tools are easier for models than to use complex tools. So instead of having a function that does arithmetic operations like add, multiply, subtract, and so forth, we created simple tools that have, like, let's say, a single responsibility: just add or multiply or subtract. So do one thing. That's useful. And also, this is important, is asking, they say that if you ask the model to select from a large list of tools, poses some challenges for the model. So this is what confuses the model. If you pass like a lot of functions and a lot of tools that have maybe even like quite different let's say purposes or goals, it would be probably harder for the model to select the proper tool. In that case, I guess you have to be very careful, and you have to be pay close attention to the description of the tools, to the name, and also to the system messages. So the guidelines and guide the LLM to pick the right tools. So that's about LangChain and tool calling on a very basic level. Keep in touch with this list and please subscribe and like, because I will be probably posting some more videos where I'm going to be using tool calling to do some things like making a call to a website or to an API and getting back a response, or accessing a database. So I'm probably going to upload some videos with some more interesting examples using tool calling. Thank you for watching. I hope you learned something useful today, and I'll see you in the next videos. Bye bye.